to be talking about models and applications. We talked about models on, I believe, the second day of class. And now that we know a little bit more math, we can expand what a model is. Okay? The different kinds of models we can use. So I'm going to have you start with this little warm-up exercise. It says your local computer store is having a terrific sale on digital cameras. After a 40% price reduction, you purchase a digital camera for $276. What was the camera's original price before the reduction? Do a little work, discuss with your table mates, and then we'll discuss together after. Okay, I saw a couple of different approaches to this problem. All of them were excellent. So the key thing here that can confuse people is, what are you taking a percentage of, right? Are you taking a percentage of 276? No, because the percentage is of the original price. So before you start doing any kind of arithmetic, you should take a minute to define all of the things you're working with. And identify the question, right? What was the camera's price before the reduction? That's the question. Use the question to help you define a variable, right? To define your unknown. So we're going to let X be the price of the camera before the sale. Okay. Now we're going to take 40% away from X. So I saw two different things that people wrote for equations here. I saw some people say, well, start with X, subtract 40% of X, and you should end up with $276. Does that make sense? Okay. Start with X, subtract 40% of X, and you get the sale price. What is 1X minus 0.4X? 0.6X. I saw several groups jump straight to this equation, thinking, okay, if you're removing 40%, that means you're paying 60%. So we could just take 60% of the original price to get the sale price. So both of those are completely awesome. Divide both sides by 0.6, and you end up with X equals, I think, $460. All right. So this whole thing of using the question to help you define a variable is going to be really, really helpful in the rest of these problems. So this section deals with models and applications. Many of you know these things as word problems, but we like to call them story opportunities. Put a little positive spin on it. So one of our goals today is to develop some strategies to help us solve these story opportunities in order to become more confident and competent problem solvers. Okay, so we have a bar graph here. It shows the average yearly earnings for the United States for people with a college education by final degree earned. So we've got bachelor's degree, master's degree, doctorate, and some kind of professional degree. So it says the average yearly salary of an American whose final degree is a master's is $49,000 less than twice that of an American whose final degree is a bachelor's. Combined, two people with each of these educational attainments earn $116,000. Find the average salary of Americans with each of these final degrees. So that, I mean, it's just like a jumbled mess when I first read it. You're like, what? Like, could they make it any more convoluted, right? So start by finding the question. It says, find the average salary of Americans with each of these final degrees. And the degrees were a master's and a bachelor's, right? So where do you begin? Identify the question. And use those to define your variables. Yes? Salary of master's and y will be salary of a bachelor's. Good. All right, so they're asking us to find two things, so we could define two variables. And then we can start to try to translate these crazy sentences. Now that we have variables to represent the things that they're talking about, it's a lot easier. All right, so for me, this sentence, combined two people with each of these educational attainments earns $116,000, is much easier to translate than the first one, so I'm going to do this one first. So two people, one with a master's and one with a bachelor's, together they earn $116,000. So x plus y equals 116. Because I think we're measuring all of these in thousands. Yeah, measured in thousands of dollars. So I just write 116 rather than 116,000. Okay, so now the tricky sentence. If your final degree is a master's, your average salary is 49,000 less than twice that of someone who has a bachelor's. 2x, 2y minus 49. Yeah, double someone who has a bachelor's. 49,000 less than that means subtract 49, and that should give you x, right? That should tell you x. So you have x, the salary of someone with a master's, take double the salary of someone who has a bachelor's and subtract 49,000. The salary of somebody with a master's is 49,000 less than 2 times the salary of someone with a bachelor's. So now I've translated everything that they gave me in those sentences using my x and my y, the variables that I defined from the question. All right, how do I solve this thing? Substitute, yeah. So I'm going to take, I have an expression for x. X is the same thing as 2y minus 49. So I'm going to take this 2y minus 49 and replace it in the first equation. So instead of x plus y equals 116, I'm going to write 2y minus 49 plus y equals 116. And then I just combine like terms and solve it. So I have 3y equals 49 plus 116 is 165. So y is, what's that? 55. 55,000 for someone who has a bachelor's. Average salary is 55,000. And for someone who has a master's, the x, what's the average salary? Yeah. So x, which is the average salary of someone with a master's, is 2 times the bachelor's salary minus 49. Now that we know y, you can put it into this equation and you get x is 110 minus 49 is 61. 61,000 average salary for a master's degree, 55,000 average salary for a bachelor's degree. Nope. Nope, does not matter what one you find first. What do you think?
You know the relationship between x and y as you're reading. You have to go through.
You do not have to use two variables. Yeah, if you can write the relationship between x and y, like if you can define it this way. Like you could have said y is the salary of a BA, 2y minus 49 is the salary of a master's without having to use a second variable. Totally fine. Yeah. Okay. Oh, I did all of this not in the grid. Sorry. Okay, so I'm going to let you try one selecting a monthly text message plan. Choosing between two texting plans, we've got plan A and plan B, and how many text messages, for how many text messages will the cost of the two plans be the same? Okay, so let's go through this together. We read the problem carefully and identify what we're being asked to find. So we find the question. For how many text messages will the cost of the two plans be the same? Okay. So the answer to that question will be a variable that we define. So we can call it anything we want. I've seen a lot of X's and a lot of T's. So let's call it T will be the number of text messages. Okay. T is going to represent the number of text messages. Okay, so I didn't have to define it just yet. Number of texts is what I'm being asked to find. Let's call it T. Okay. Write all other unknown quantities in terms of this variable. So what are my other two unknown quantities here? The cost per month. Yeah, the cost of plan A and the cost of plan B. So the cost of plan A we'll call A, and B we'll call the cost of plan B. So what does A equal? What is the cost of plan A? $20 plus 0.05 times T, the number of texts. 20 plus 0.05 T. And then the cost of plan B, what is that? $5 plus 0.1 T. 10 cents per text. So you multiply 0.1 times the number of texts. Okay, what equals what? A equals B. That's what we're trying to find out. For what value of T does the cost of the two plans equal each other? So when does A equal B? When does 20 plus 0.05 T equal 5 plus 0.1 T? Combine like terms, so I'm going to move the 5 over to the left and I get 15. Move the 0.05 T to the right and I get 0.05 T. Because 0.1 minus 0.05 is 0.05. Divide both sides by 0.05 and you get T equals 300. So what's the answer to the question? 300 texts. Yeah. So if you forget what the heck you were doing, like you got lost in the algebra, you go back and you go, oh, T represents the number of texts. I wrote it up here. So we need to write an answer to the question. So 300 texts. All right, so if you're going to do less than 300 texts, you would choose which plan? Plan B, the one that's more expensive per text. Less than 300, choose plan B. If you're going to do more than 300, choose the one that's less expensive per text. Plan A. Okay, it's good practice to check your answer. And I'm going to show you how to do this graphically on a calculator and in GeoGebra. Okay, so we did this a little bit last class. It's just that our equations didn't represent anything before. So I'm going to let y1, instead of calling it A, there's no A in my calculator, so I'm going to let it be y1. That's going to be the cost of plan A, which was 20 plus 0.05 T. And y2 will be the cost of plan B, which is 5 plus 0.1 T. And I'm going to put those things into y1 and y2. So I go to y equals in my calculator. And I'm going to graph 20 plus 0.05. Have to use x. There's no t variable in my calculator. And then in y2, I have 5 plus 0.1 x. If I didn't know the answer, I would start with a standard window. So zoom oops, zoom 6. And I have negative 10 to 10, negative 10 to 10. And I can only see one of the lines, right? So which line am I seeing? Can you tell? It would have to be the one with the 5 because it has a y-intercept of 5, right? What's the y-intercept of the plan A line? 20. So I need to go at least up to 20 in my window. So I go to my window and my y max needs to go at least to 20. Maybe I'll go to 30 and see what I can see. So it looks like they're going to intersect like way to the right, like they're heading towards each other, but real slowly. So let's change the window drastically. I'm going to start x min at 0 instead of negative 10. Since x is representing the number of texts, we don't have to consider negatives. I'm going to go way to the right because it looks like they're going together real slow, so maybe 500. And let's try that. Oh, I need to go up a little bit more. Window, so instead of y max of 30, maybe 50. All right, so I can now see the intersection point, and I use the calculate menu. So you do second calculate, it's right above trace. Choose option 5, intersect, and it asks, is this the first curve? You say yes by pressing enter. Is this the second line you're curious about? You say yes by pressing enter, and then you guess. You just put the cursor somewhere near the intersection and press enter. And I have 300, 35. The 300, we already agreed that represents the number of texts. What does the 35 represent? Yeah, that's how much y1 and y2 will equal, and those things represent the cost of the two plans. So for 300 texts, the cost of plan A and plan B is the same, and that cost is $35. So we can look at the table as well. So we go second table. If I type in 300 texts, 300 for X, you can see that Y1 and Y2 are both 35. So the cost is the same for those two. If I do something less than 300, like 100 texts, then my cost for plan A is $25 and plan B is $15.
So you can figure that out algebraically by just punching it in.
Exactly. Yeah, you can figure this out algebraically. We're just having the calculator do the work for us. For 300, we know they're both $35. After 300 texts, like if we did say 350, then Y1 would be $37.50 and Y2 would be $40. So 300 is like the cutoff, right? If you're trying to decide which texting plan to get, it depends. Are you going to send more or less than 300 texts? So just real briefly, I'm going to show you how to do the same thing in GeoGebra. Okay, so here's GeoGebra. It's the exact same process as the calculator. We're going to graph the two lines, a line that represents the cost of plan A and a line that represents the cost of plan B, and find where they intersect. So I'm going to graph y equals 20 plus 0.05x and y equals 5 plus 0.05x. So I've got two lines. I can't see one of them, just like happened with my calculator. So I just have to, did I mess something up? Oh, this one's 0.1, right? Thanks. 0.1, good. Okay, so just like with my calculator, I'm going to have to mess with this window till I can see both lines and where they intersect. So now I can see both lines. I need to look at more x's. And there, I can see the intersection point. To find where they intersect, in the input bar, we just type intersect, square bracket, and then the lines that I typed in, GeoGebra named them A and B. You can see that in the algebra view, so I just type A comma B, enter, and it gives me this point. And I can make the algebra view a little bit bigger to be able to see those coordinates. And I showed you last class, if you right click on this point and do object properties, here in show label, we can do name and value. And then on the graph, it'll show point A and its coordinates. Okay, so last thing we're going to cover today is solving a formula for one of its variables. So here's a model that you may be familiar with, D equals RT. And we say that this formula is solved for the variable D because D is alone or isolated on one side of the equation, and the other side has no D's in it. So this model is useful for situations where you're asked to find a distance given the values of rate and time. D represents distance, R represents rate, and T represents time. But sometimes you may want to rewrite this formula or this equation so that we can solve for R or for T. So if I have D equals RT and I wanted to solve for T, what would I do? Yeah, well, yeah, how do I?
By T. Or you said you're finding T?
I want to get T by itself. Yeah, I want to solve for T. Close. Divide both sides by R. If I wanted to get T by itself, I'm going to divide both sides by R. They'll cancel on the right, and you end up with T all by itself equals D over R. And then you can put it on the left if you want. It means the same thing. T equals distance divided by rate. Make sense? All right, let's look at another one that's just a little bit more complicated with the algebra. I have the formula A is equal to principal, like an initial investment, plus your principal times an interest rate times time. So this is how money earns interest in a bank, right? So you always have the initial amount you put in, and then this second term represents interest, right? How much interest have you earned, where you multiply the amount you invested times some interest rate times the amount of time it's been in the bank. So I want to solve this equation for P. So I want to know what P equals. So I want P all by itself, other stuff on the other side of the equation. Subtract PRT to the other side. So I have A minus PRT equals P. So the problem with this, we've gotten P by itself, right? But there's a P on the other side also. So this is kind of like using a word in its own definition, right? So you can't, we need to define P in terms of only the other variables. So this is not quite it. Nico, do you have your hand up? Same thing's going to happen. You're still going to have a P on both sides of the equation. You're on the right track. No. What do you notice about both of these terms? This is the problem, is that in both of these terms there is a P, right? Is there something we can do when a factor shows up in both terms? Pull it out. You factor it out. So I'm going to have P times what? 1 plus RT. Now, if I wanted to get P by itself, this is multiplied, right? P times 1 plus RT. How do you undo that multiplication? Divide both sides by 1 plus RT. So on the right, the 1 plus RT's cancel, and the P is left all by itself. And on the left, I have A divided by 1 plus RT. Yeah. It's a little bit tricky. Just to know that the trick is when the variable you want to solve for is in two terms, you want to factor. Factor, factor, factor. All right. I have 3 problems for you to try in your groups.